Now it's time to prove that we engineered our car correctly. In this video, we're assembling our functional zone, and we're going to find out if this design actually works. By default, Fusion opens up in part design. We're going to switch over to an assembly and our car project folder where all of our parts are saved. Since everything connects to the chassis, we're going to bring that in first. Leave it grounded. We don't want this thing moving. Now, we're going to bring in our first axle, get it close, then define the relationship using joint. Select the end of the axle. Then the hole in the chassis. It's aligned, but not positioned correctly yet. Now we're going to slide it in so both sides stick out evenly. And now we need to fix the motion. By default, this is rigid, but this is an axle. It should rotate. So we change rigid to Revolute. Now we can preview the motion, and it confirms that it spins the way we expect. Repeat the process for the second axle. Move it in place. Snap point, snap point. Set it to Revolute. And then align it from the top view so that it matches the first. Now both axles are in place and both are able to rotate. Now we're going to start bringing in the wheels. Move wheel 1 into place. Apply the joint and snap the wheel to the axle. Now, Fusion may default this to Revolute, but that's wrong in this case. The wheel should not spin independently from the axle. So we need to go back, edit the joint, and change it to rigid. Now the wheel is locked to the axle and moves with it. Repeat this process for all 4 wheels. And now we have the full assembly. This is where Fusion goes from being a CAD, computer-aided design, to computer-aided engineering. First, let's inspect our design. Tool number 1 is going to be measure, and we're going to check how far the axle sticks out on each side. Here we can see it's 4 inches. Checking the other side, we can see this one is 3.6. That's not centered. We're going to need to fix it. Since these parts were already joined, we don't move them directly. We edit the joint. Adjust the position values. And bring both sides into alignment. Repeat the process for the second axle. And now both sides match, and the car is centered correctly. Next is interference. This checks if parts are colliding. If everything is correct, we should see no interference detected. We also want to check the coincident faces. And in this case, we find a problem. This is showing us it's a perfect fit, but that's actually a problem. In the real world, perfect fits don't move. If there's no clearance, the axle won't spin. This is where parametric design pays off. We're going to go back into the chassis file and fix the hole. Instead of having an axle diameter reading axle diameter, we're going to change that to axle_diameter times 1.05. That gives us clearance so the axle can rotate. We're going to make sure both holes match, and while we're here, we're going to move those holes just a little bit further in from the edge. Now that we've done that, we're going to save our chassis file. Go back into our assembly and hit the update button. Now let's run interference one more time. Select our 3 parts. Compute. Now, no interference detected. Now, we test motion. Go to Motion Study. And we're going to select our axle joints. Now we need to add in our keyframes for our motion study. We're going to click here, and we're going to have this axle spin 90 degrees. Second keyframe, we want it to have spun to 180 degrees. Third keyframe, 270 degrees. And our fourth keyframe, 360 degrees to complete the full rotation. Now we're going to play it on a loop. And watch our axle spin. Now we're going to repeat adding those keyframes in for our second axle. And now the full system moves. Now you've proven your car actually works. You've assembled it, tested it, and fixed real engineering problems. In the next episode, we're leveling this one up and making your design completely unique. If you found this video helpful or you learned something, go ahead and click that subscribe button. And I'll see you in the next one. Let's keep building.